In this class, we'll be looking at an atom. An atom. What is an atom? An atom is the building block of a matter, and atom has three particles: the proton, which is positively charged; the neutron, no charge, is neutral. It's neutral. And we have the electron, that is negatively charged. So for us to discuss an atom effectively, we need to know the atomic theory, where it started and where we are today. So we'll look at the Democritus theory. That is C400 BCE. And this is where it was proposed that matter is made up of tiny indivisible particles called atom. And this was not supported by any experiment. It was purely theoretical. It was purely theoretical. So in 1803, John Dalton did his own investigation based on experiments. And here he proposed that all matter is composed of atoms. Atoms cannot be created nor destroyed. And said that compounds are formed by the combination of atoms in a fixed ratio. They said that atoms of the same elements are identical. This was what John Dalton in 1803 proposed. And then J.J. Thomson came up with his own in 1897. And this was where an electron was discovered based on the experiments he performed using the cathode ray tube. And this is where he proposed the plum pudding model, that the electron is embedded in a positive sphere. Then the next was Ernest Rutherford, 1911. This is what we call the nuclear model. The Goldford experiment showed that atoms have small, dense, positively charged nucleus. And then the next, Neil Bohr, in 1913, here he said that electrons orbit the nucleus in a fixed energy level. And let me now explain. When you talk about the nucleus comprises of proton, and neutron. And on this, that is what we'll talk about the orbits, or what we call the shell, where the electron is always revolving. This electron is negatively charged. As we have said, the proton is positively charged. The neutron has no charge, and the electron is negatively charged. So the combination of proton and neutron is what forms the nucleus of an atom. And it means that the nucleus of an atom is positively charged. And the electron that is negatively charged, which also has a mass that is negligible, is revolving on the fixed orbit according to Bohr's theory. So it means that there's a force that exists between the proton, the nucleus, and the shell where the electron is orbiting. Now we have from the electrostatic force, or what we call the Coulomb's force, we have what we call like charges. Like charges means it could be positive, positive, negative, negative. These are like charges. Then we also have what we call unlike charges. It could be positive, negative. So from the electrostatic force or Coulomb's force, like charges repair. It means that if you have positive, positive, they will repair. If you have negative, negative, they will also repair. Then if you have positive, negative, these are unlike charges, they attract. So coming here, the nucleus is positively charged. The electron, or the orbit where the electron is revolving, is negative charge. It means the electrostatic force, or the force existing between the nucleus and the orbits, will be attractive force. So according to the Bohr's theory, the electrons orbit the nucleus in a fixed energy level or shell. And it means that the electron can jump from one energy level to another. And that is where we'll talk about the atomic emission spectra. Atomic emission spectra. That is about the Bohr's model or theory of an atom. Then we also have what we call the quantum mechanical model from 1920s to present. This model is developed by Schrödinger, Hesselbank, and others. And they say that electron exists in the probability cloud called the orbiter. And this orbiter is not fixed, it's not a fixed part. And he described the atomic behavior with quantum mechanics. Quantum mechanics. So the rundown of this atomic theory starts from the Democritus, which is from c. 400 BCE, to John Dalton, 1803, J.J. Thomson, 1897, Ernest Rutherford, 1911, Niels Bohr, 1913, and the quantum mechanical model, 1920, till present. So why the question is, why are we studying this? Why are we interested in this atom? Knowing the atomic theory has a lot of benefit and importance, has a lot of applications. For example, in the study of chemical reaction, we need to understand this. We need to understand this atomic theory. It's applicable in understanding the chemical reaction. 2, development of nuclear energy. 3, spectroscopy and quantum physics. And 4, the modern medicine. For example, we talk about radiotherapy and so on. These are the applications of atomic theory. So in our next class, we'll be talking about select a particular model and discuss, and then we'll look at the applications. Thank you.